Hello, this is Mr. Stansbury. I'm going to take you through the notes on similar figures. At the end of this, you should be able to say, I can use the properties of similar figures to determine if two figures are similar and to find missing measurements of similar figures. All right, so first thing, two figures are similar if the figures are equal angular, meaning all the angles are the same, they all match up, and also the corresponding side lengths have the same ratio. Okay, so let's take a look at some examples to try to see if we can figure that out. Okay, so let's take a look and see. We're going to determine whether the following figures are similar. Okay, so we're going to see if this is similar to that, if this is similar to that. So in order for that to happen, if you remember from our definition, all the angles have to be equal angular, so they all match up, and then also the ratios of the sides have to be the same. So since all these angles are 90 and all these angles are 90, we're set on that. So let's check the ratio of the sides. So long side's 14, short side's 7. So we can do this. You can set it up several ways, but I'm going to do 14 is to 7 on this one. Does that equal, long side is 18, short side is 9. So we've got, does that equal 18 over 9? Okay. Right, so what we can do is just do a little cross multiply here, right? 14 times 9 should equal 7 times 18. 14 times 9 gives us 126. And then 7 times 18 also equals 126. So that is true. So therefore, they are similar. Similar figures. Okay. Now, you also could have simplified each one of these fractions if you saw that. So 14 over 7, you could say, hey, wait, that's just 2. And then 18 over 9 is also 2. So that would also work. Okay. A lot of people get confused and like, oh, how do I set it up? So again, I set mine up as my long side on one to the short side on the same one. Does that equal the long side to the short side? You could really set it up as long side on one. I could have set this up as long side on the first one over the long side on the second one. Does that equal the long side on the first one over the short side on the first one over the short side on the second one? And you will end up with the same, multiplying the same numbers. So you got, look, 14 times 9 and 18 times 7. So 126 will still equal 126. So you can set it up many different ways. The big thing I always try to remember is if like these two things should have something in common and these two things should have something in common. Like the 14 and the 18, those are both the long sides. And then the 14 and the 7, they're both on the same figure. The only thing that would get us into trouble is if in either one of those spots we had the 9, because the 14 and the 9 really don't have anything in common, because that's the long side on one and that's the short side on the other. Okay? Hopefully that makes sense. Anyway, let's take a look at another one. So we've got to look at this, and we got to figure out we got to figure out what corresponds to what. And actually it's pretty nice here because it says A prime, C to C prime, B to B prime. So what we are going to have to figure out here, we can't tell about all the angles, but if all the sides are proportional, have the same ratio to each other, then that means that it has to, all the angles also would have to be the same. So let's check it out. So let's do AB, the long side. So AB of the long side on the first one is 16 over, and then let's do AB on the smaller one, the long side on the image, and the pre-image is this one, right? So over 11. Excuse me. Does that equal? Let's go say AC. This short one here. AC is 6, and then on this one AC is 4. Okay, so then we're going to do little cross products. 6 times 11 does that equal 16 times 4? Let's figure that out. Okay. Well, 6 times 11 we know is 66. So then let's do 16 times 4. And that gives us 64. So that is not equal. So since we have one that's already not doesn't have the same proportion, then that means that these are not similar. So therefore, not similar. Not similar figures. Okay? All right, let's look at one more, and then off we go. So, example 2, these figures are similar. Find x rounded to 2 decimal places. So, they're saying these are the same. It's like these are not the same, but they're similar. They have the same ratio. So, just like what we did before, let's just set these up. So, let's do on this one here. Let's say BC. We know that BC is 14. So then we'll look for B prime C prime. So B prime C prime on this one is 8. And then let's see, we need the CD part. So CD on the big one is 22. And CD on the small one is X. And now we can do cross products. Okay. One other quick thing on this here, 14 and 8. So these these here came off of, these are the BC sides. So both of those are BC. Let's see, both 22 and the X. So 22 and the X, these are both DC. So this is just another way to check to make sure you're getting all set up right. And then we could say do this one, the 14 and the 22 are both on the pre-image. Okay, so these are matching up. And then the 8 and the X are both on the image. So let's do, sorry, just looking for a different color here. So these are both on the image. So as long as they line all up like this, so so that they're together, then you know you've got it all set up right. Okay, so I'm going to undo all that and go back so that we can do our cross multiply. Okay, so with these here, we got 8 times 22 is going to equal 14 times x. So we got 14x equals, let's see, 8 times 22 gives us 176, right? So divide both sides by 14, and we get that x equals, 176 is already in there, divide by 14, and we get 12.57. It says to 2 decimal places, so there's a second decimal place. 1 tells the 7 to stay the same, so we are 12.57 is what x is going to equal. And since there's actually labels on there, let's put our labels on here, centimeters. Okay. All right, that's all there is for similar figures. If you have any further questions, please feel free to ask. Thanks.